Hi everyone, welcome to this session. Now in this session, the agenda is discussing a very interesting topic of permutation combination, which is called as grouping. Okay, grouping typically takes care of the fact that all your distribution and everything comes into the same bracket. It is actually termed as one of the difficult areas of permutation combination. Let's see if at all it is difficult. So I'll start off this session by asking you a simple question, and that question is, please pay attention. In how many ways 15 identical 15 identical chocolates could be distributed to 4 kids? Okay, now I can very well say that this is not at all a very difficult question. You can actually use some permutation combination logic to answer this thing, but the way through which I'll be explaining this to you is something called as a partition method. And in the partition method, I'll employ certain tactics through which you can arrive at this idea or this situation. It is also important to understand that we will employ formulas at the later stage of our sessions, but then to understand the formula, the method of partition will be immensely useful. All right, so again, let's get back to the situation. The situation is a pretty simple one: 15 chocolates, 4 kids. So first of all, let's see, if I have these 4 kids. I'm not very good at drawing, so please make do with it. Again, all of them are happy. So let's say one of the distribution scheme could be I employ 4 and 4 to the first two, 3 and 4 to the next two students, or the kids, you can say. If you see, there are 8 and 11 and 15 chocolates. So this is one of the methods of distribution. Another method could be I can give the first one 2 chocolates, the second one, let's say 1 chocolate, third one 1 chocolate, and then 11 chocolates to the last one. So this is also one of the let's say accepted conditions. One more condition is that I give 0, 0 and 0 chocolates to all the first 3 students, and then I ended up giving all the 15 chocolates to the third kid. There could very well be a possibility that I don't give anybody any chocolate, because that is also a possibility. In other words, if you have to model the same question, I would want to take your attention to this part. In English language, straight up, what you need to understand is that, suppose for the 4 kids, I introduce variables as x, y, z, and a. Now, obviously, these x, y, z are variables, and because the kids were all distinct, obviously the kids has to have distinct this thing, right? Because they're physically different student. But in theory, we will find a case where you can also have identical distributions, but that will come at a later stage. Effectively, what I'm trying to tell you is that all you need to tell me is all the solutions, and when I say solutions, the whole number solutions to this expression. Okay, x plus y plus z plus a, that is equals to 15. Now, if you have done this question, I don't see how you will find it any difficult. But if this is the first time, please pay attention to this thing, because you'll understand this better. So let's say the 15 chocolates, let me try to make you visualize the 15 chocolates. Okay, so let's say this is the 1, 2, 3, and 15 chocolates. Okay, so these are all identical chocolates. To distribute them, all I need to do is just create partitions. Okay, so suppose I create a partition over there and I create a partition over there. If you see, it is very important for you to create partitions which are going to be one less than the total number of variables that are there. Because if you create, let's say, 3 lines or 3 partitions, only then you will be able to distribute the 15 chocolates over there into 4 areas. In this case, the first student can get 3 chocolates, the second student will get 6, and then 2, and then 4. If you add, this becomes 10, 12 and 15. Okay. Now if I, let's say if I make a partition over here, and I make a partition over here, and I make a partition over here. So in the first partition I'm getting 2 chocolates. In the second partition I'm getting 3 chocolates. In the third partition I'm getting 3 chocolates. And the fourth partition I'm getting, can actually check. No matter where you design the partitions, as long as you design 3 partitions, you will always get the 15 chocolates. The 15 chocolates are there. It's just that the partitions divide them. Now I will take you to the idea. All you need to do is arrange the dots. Okay, arrange the dots and the lines. The question is 3 lines or partitions that divide the 15 chocolates into 4 groups. Okay, will give us the whole number solution to this condition. Now in how many ways can you do the arrangement of those 15 dots and 3 lines? I'll give you some time to think on it. The answer to that is going to be, let's see, that is going to be 18 factorial by 15 factorial into 3 factorial. I'll explain everything, don't worry. Okay, what is this 18 factorial? This is 15 dots plus those 3 partitions. We can call them partitions or lines, whatever. 15 dots plus 3 partitions. What is this 15? Why is it exactly we're dividing by 15 factorial? Because please understand, these were 15 identical, okay, identical dots. You can call them dots, you can call them stars. Okay, instead of this partition, if you feel like calling the partitions as, you know, let's say bars or whatever, you can call these bars also, because there is a very popular lingo which talks about stars and bars method of counting whole number solutions. Okay, so these 3 partitions, if you pay attention, these 3 lines are also identical. The students, however, were all distinct. The kids were all distinct, but the lines are all identical. So that is why we have to divide it by a 3 factorial over there also. And if you pay attention, this 18 factorial by 15 factorial into 3 factorial, this is nothing but, let me go back to the screen so that you will be able to visualize that better. Okay, let me take you back to the screen. And let me create some space so that I can, you know, make you visualize this thing a little better. So here, just now I have mentioned the number of possible arrangements are going to be 15 factorial, rather 18 factorial divided by 15 factorial into 3 factorial. If you pay attention, what exactly is this number? This is n plus r minus 1 c r minus 1. Is this not the formula that you have been asked to mug up? But now I have given you the explanation. You don't really need to mug up anything. All you need to ask yourself, how many dots and how many lines. Okay, so suppose I have 15 dots. Okay, if I have 15 dots, all I need to do is add the lines to it. So 15 dots and 3 lines will make it a 15 plus 3 factorial. And because I have 15 identical dots and 3 identical lines, I'll write it like this. So this is going to be 18 factorial upon 15 factorial into 3 factorial. I'm just reiterating myself so that this idea becomes, you know, rock solid in your mind. For those of you who still have some problem of understanding why is it that we are dividing by 15 factorial and 3 factorial, you know, let's say for some reason if you have skipped the earlier conceptual ideas of PNC. So let's say the numbers A, B, B, C, 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 and we have to arrange them. If you pay attention, they are all total 6 let's say letters, 6 letters divided by the numbers of B that have repeated, that is going to be 2 factorial, into the number of C's that have repeated, that is 3 factorial. Now this is a very simple idea of PNC that we start off by. This basically makes sure that you're not double counting any number, you're just taking one arrangement as it is. Okay, now I would like to give you the types of questions that can be asked in an aptitude based exam like that of a CAT. If you go into the depths of combinatorics, there could be a lot many cases that can be designed, but mota mota, questions that cat can ask. Okay, and I'm saying this after basically looking at all the 70-80 questions that have come in the PNC probability chapter across all the years. And you'll be surprised to know that there are around about 10-12 questions from the chapters of probability, and that is perhaps one of the reasons students leave the chapter entirely. So in all these 20-30 years of CAT, there are only 12 questions from the area of probability. Probability is a very remote area, so I'm just giving you an anecdote over here. So the question types, okay, so the question type, the first question type that you can encounter is that how many numbers less than 10,000 adds up to 15. Now don't worry, I'll give you exact idea of these things. So how many numbers less than 10,000 adds up to 15? This is one of the question types. Basically what you need to do is that anything less than 10,000 will be a 4-digit number, yes or no? Those 4-digit numbers can again be looked at like this. So let's say I take the numbers, the representation of these spaces as A, B, C, D. They just needs to add up to 15. But then there is a condition, and please remember the condition is that A, B, C as well as D has to be less than or equal to 9. It cannot be more than, because these are all single digit numbers, right? So you cannot substitute. And also you need to take care of the fact that A cannot be 0. Actually, the fact of the matter is A can be 0, because I'm talking about all the numbers. So we can take the, let's say a single digit number, 2-digit number, 3-digit number. So you have to be careful. So just because blindly somebody is saying that A cannot be 0 is not going to be the case. You need to see what the condition is asking you. All right, so let's look into the next question type. The next question type that can be asked is, let's say 4 dice are thrown. I'm not going to write the entire thing. The question is, what is the probability? And this is one of those questions that has been asked. What is the probability of getting a sum of 15? Probability of getting a sum of 15. Okay, this is one of the question types. Again, nothing, all you need to do, so I'll explain this question type a little bit. So this is again 4 spaces, okay, and in those 4 spaces any number can fall. So I am actually giving you an upper limit as well as a lower limit. So the upper limit is for A, B, C and D. Again, let's assume that these spaces can be filled by A, B, C, D numbers. So A, B, C and D can be collectively equal, less than or equal to 6, and at the same time A, B, C and D, because of the nature of this dice itself, it has to be greater than or equals to 1. So you just need to take care of the conditions. Please understand, most of the times we don't get a very high accuracy in permutation combination is because students tend to leave out on the essential conditions that are given in the questions. Okay, now one more very important question type that can be asked from this area is a question type A plus B plus C plus D that is less than equals to 15. Now please pay attention. I have given you the tactics to handle an equality and not an inequality. So you have to be very careful when the expression is of this form. Okay, so what is exactly that I need to do in this situation if I have an inequality there? We'll talk about that, no, don't worry. But as of now, all I'm telling you is that you have to pay attention to the criticality or the nuances of the question types. We'll discuss everything in greater details, don't worry. And then the last one is the grid based problem. I have already given you a snippet in the chessboard puzzle that I have shown you a couple of days ago. So a typical chess kind of a situation, not chess exactly, but a grid situation will be given to you, something like this. And suppose an individual is over there. So let me try to draw. So this individual is over here and he needs to reach this position B, and this individual can only travel horizontal in this direction and vertical in this direction. Because if you pay attention, this grid type question will become in, the number of solutions, be it a whole number solution or a let's say natural number solution. I'll discuss the natural and whole thing also, but then it is very essential for the individual to move in the horizontal this direction and vertical this direction, because if you allow him to come down and go to this direction, there will be infinite possibilities. So that is something that will be very specifically mentioned in the question itself. All right, so I think this is all the question types that you will ideally get in a let's say exam condition. So let's start with the next part of this video. Okay. Okay, so let's do one question before I conclude the session. So let's say I have, let me give you the idea of the one that I was telling you, the natural number idea, right? So let's say I have the number a plus b plus c plus d, and that is equals to 15, which is given to you. And the question is very specifically telling you that a, b, c and d has to be greater than equals to 1. What this means is that the idea that any one of them can be 0 is not allowed. Now there is again a formula, but we don't, subscribe to formulas. At least we don't subscribe to them blindly. Obviously we will remember that and we will appreciate that after a, decent point in time. But now let's just say if everything has to be greater than equals to 1, let's just give everything 1. So what I get is, I get 4 over there. I'll subtract. So 15 minus 4 is what? It is 11. Now, the moment you give away 1, 1, 1 to each ABCD and you get this thing as 11, it's as good as the previous expression itself, and now you are allowed the whole number solutions. Okay, so now it basically becomes a1 plus b1 plus c1 plus d1, that is equals to 11, and the same thing holds true for this one. Remember, for a, if you get a 0, and for b, if you get a 0, remember the actual solution will be 0 plus 1. So ideally you will get a, whatever 0 number you get, you will add 1 to it, because we have subtracted 1 from this thing. And again guys, I am not going to give you the answer to this. It's very simple. Okay, at this point you should have said, sir, this is going to be 14C3. Okay, but for those of you who are not very comfortable with the NCR notation, just say this thing in your mind: 11 dots and how many lines? Please tell me. There are going to be 3 lines. Okay, for those of you, you will struggle if you're looking at this for the first time. You'll struggle, so you don't have to jump at this thing 14C3. This will come, naturally. As of now, all you need to do is 11 dots and 3 lines. How many ways I can arrange them? 11 dots, 3 lines, that is going to be 14 factorial. 11 factorial into 3 factorial. Why is it that we are dividing by 11 factorial? Because 11 are of same one kind and 13 are of one. Let's not use the word one kind, another kind. Let's use the word 11 are identical, 3 are identical. Okay. And this thing, my friends, is as good as 14C3. You can actually compute the values and you'll get the same value. Okay. Now, let me give you a homework for those of you who are gonna be looking out for something. So I'm just giving you a very simple number, and I'll be really happy if you compute this one. So you just need to compute the whole number solutions to this expression: a plus b plus c is equals to 0. Sorry, not 0. A plus b plus c is equals to 50. Okay, so this I am giving you as a homework. So if you feel like you want to answer this thing, you can answer it. Okay. The same idea, you'll just use the dots and lines and you will arrive at the answer. So if you did enjoy this one, please do mention that, because I'll make many more videos on this topic. And obviously this is just the beginning of partitions. The other videos will go in depth. We are going to be going in depth in this concept. Thank you.